In this video, we are going to look at hexagonal architecture, also known as the ports and adapters pattern. It is a way of structuring a system so that your core business logic stays completely isolated from the databases, user interfaces, and third-party services it works with. By the end, you will know why that isolation matters, how the structure is built, and when to reach for it. Imagine you have built an e-commerce system. The pricing rules, the discount logic, the order validation, all of that business thinking is scattered across controller methods, database calls, and HTTP handlers. Now your company wants to replace the database or add a message queue consumer alongside the REST API. Suddenly you are touching the heart of the application just to swap out infrastructure, and every change risks breaking something completely unrelated. That is the pain hexagonal architecture was designed to cure. Think about the ports on a laptop. The laptop itself does not know or care whether a USB port is connected to a mouse, a keyboard, or an external hard drive. Each device is simply an adapter that conforms to the port standard. You can swap any device without opening the laptop. Hexagonal architecture works exactly the same way. The application core defines ports as contracts, and the outside world connects through adapters that fulfill those contracts. Here is the structure. The domain core sits in the center and contains nothing but pure business logic. No framework imports, no database drivers. Around it are two kinds of ports. Driving ports on the left are interfaces the core exposes so that callers like a web UI or a message queue can trigger it. Driven ports on the right are interfaces. The core declares that it needs, for example, a way to save an order without knowing what fulfills them. Adapters on the outside implement those interfaces, wiring real technology to the abstract ports. Crucially, every dependency arrow points inward toward the core. Trace a real request. An HTTP call hits the REST controller, that is a driving adapter. The controller translates the HTTP details into a plain method call on the driving port interface. The domain core picks up that call, runs the business rules, and when it needs to save something, it calls the driven port interface. It has no idea whether that interface is backed by Postgres or an in-memory store. The driven adapter, the real database implementation, fulfills the call, and the result travels back up the chain. The core never touches infrastructure directly, which is the key consequence of this design. Hexagonal architecture pays off when your business logic is genuinely complex and needs to outlast the technology around it. The ability to swap databases or add new entry points without touching the core is valuable, but it comes with a real cost. You write more interfaces and more glue code, and for a simple CRUD service that just reads and writes a single table, that overhead is waste. Ask yourself whether you have real business rules worth protecting before adding all that structure. When you start building with this pattern, resist the urge to open a database connection first. Model your domain logic as plain objects and methods, then ask, what does this logic need from the outside world? Each answer becomes a driven port interface. What calls into this logic? Each answer becomes a driving port. Write adapters last in their own packages, and enforce the rule that nothing inside the core imports an infrastructure library. With that discipline in place, your test suite can run the entire business logic in milliseconds using simple in-memory adapters. To sum up, hexagonal architecture keeps your business logic at the center, shielded from the technology around it. Ports define the contracts on both sides of the boundary, and adapters do the translation work. Because all dependencies point inward, you can replace a database, add a new UI, or swap a third-party service without ever touching the logic that matters most. It is a powerful pattern. Apply it where that protection is genuinely worth the extra structure.